Good. So it's my great pleasure to be here talking about how we can build performant apps. My name is Junfeng Yang. From these two logos, you can probably tell that I actually have two jobs. I'm a professor at Columbia University, specializing in software system research. We're also doing a startup called Nimble Droid, a Columbia spin-off that aims to automate software engineering as much as possible. So regardless of which job I'm at, I have this one unified passion, helping developers build excellent software. And I've spent many years, like over 15 years, doing research, teaching, and development in building great developer tools. And also the tools we build have helped developers working at some large companies or open source projects. So right now we're focusing on helping mobile app developers to build great apps. And right now we focus on actually app performance. So why should we care about app performance? Well, because the users have really little tolerance on sluggish apps. There is a study done by this company called App Dynamics that shows 8 out of 10 users deleted an app because of performance issues. And this is a comment taken from Google Play. It's about this ABC News app. And as you can see, the user was not happy with the slow starting of this app, so the user uninstalled this app. So we know performance matters. It matters hugely for user engagement and user conversion. And also, we've been talking to a lot of developers. And a lot of these top app developers, they're already spending tons of resources making their app really fast and fluid. For example, Instagram spent over a year making their app start faster. They also rewrite their app's layout. And also, we talked to like Facebook developers, Twitter, New York Times. A lot of these top apps, they can afford to spend a lot of resources making their app faster because they have internal data to show that app performance matters hugely for user engagement and conversion. Okay, so we want our apps to be one of these tops as well. So we want to spend resources to make app performant. But how do we do that? I strongly recommend that you guys set up this performance optimization process. We want to continuously measure our app's performance to detect regressions when our apps is not performing as expected. And once we find such regressions, we want to spend time getting more fine-grained measurements to track down the issues. We need to study some open source projects. We may need to learn about how to tune performance, but it's worth it. We want to make our app really fast. And once we figure out the issues, we want to fix the code and want to measure again to make sure our fix actually works. And we want to repeat this process as often as possible. For example, for every pull request, or for every testing build, or for every beta and alpha release, so that we can catch performance regressions the moment they're introduced. Okay, so how do you actually do this if you don't have any other service to use? Well, first of all, if you want to implement it by yourself, you need to set up a device cloud. And typically, you guys probably have experience with Genymotion or other Android emulators. But these emulators, they're not faithful in terms of getting your performance numbers. So if you want to monitor your app's performance, you need to build a device cloud that requires investment in provisioning the servers or the devices. And also you need to roll out your own software to manage the devices. And more importantly, there are a lot of metrics that cannot be easily acquired using existing tools. So you may need to modify the Android runtime a little bit and also make sure that your performance measurements are stable across builds so that you can catch regressions. If your measurement has a large error, let's say like 5% error, then you can only catch regressions larger than 5%, which is not ideal. And also you need to write performance tests, ideally for all the important usage scenarios of your app. You want to write a performance test to measure, to benchmark how long it takes for these usage scenarios to complete. And also, you may need to get some performance experts to be on your team because based on our analysis, a lot of the app performance problems are not caused by developers' code, but actually caused by Sdks problems. And if you see that this SDK is acting up, your app has this large delay in terms of starting up, you may actually need to either bug the SDK developers or figure out alternatives or understand what exactly is the problem. So this requires a lot of domain knowledge. So before I continue talking about our stuff, right? Apparently from this you can tell that building your own infrastructure can be very expensive, time-consuming, and sometimes can be very hard. So how many of you guys write performance test cases? Raise your hand. Okay, so maybe 5 of you guys. Good. And how many of you guys adopt continuous integration testing? All right, a lot of you guys. So I strongly recommend you guys add performance testing to your continuous integration setup. You want to basically monitor your app's performance across builds so that you can catch problems early on. So you think about crashes, sometimes when you get a crash, you can see this like file name and line number. So crashes are somewhat easier to track down. If you think about performance, all of a sudden your app becomes like 30% slower, and you may have like committed 20 or like 100 commits. And tracking down such root cause may not be easy. So you want to basically do frequent performance testing, integrate it with your CI process. So all this is nice, takes a lot of resources. If you guys have the resources, go ahead and build it. And we're happy to share with you our experience, like building your device cloud, making sure your performance numbers are stable across builds. But if you don't have the resources, there's one thing you can try, which is our Nimble Droid service. It's a service that provides automated performance analysis for every build of your app. We designed it to be really easy to use. You don't have to install any SDK whatsoever. You simply upload your APK through our website, a few clicks, or you can integrate it with your Gradle file so that you can run a command and just upload your APK. Or you can use our website API, run a curl command to upload the APK. So once you get the APK, we're going to run it on our device cloud. And we have also implemented this intelligent app crawler that can crawl your app's interface. If your app requires login, you can supply us your test username and the test password, and we'll try to auto-login your app for you. And for each possible action we discovered for your app, we're going to benchmark the action's response time or speed, how long it takes this action to complete, and also whether this action is smooth, whether there are dropped frames. We also measure the memory consumption, disk consumption, and a lot of different metrics. And also, we don't stop just there. We also give you guys actionable diagnosis. For example, if you find out that certain methods slow down your app, we'll tell you the exact methods you need to look at. We also detect memory leaks, and they can be very bad for users, because if your app consumes a lot of memory, garbage collections run frequently, your app can be very slow, and sometimes your app crashes as well. And so some of this technology was actually initially created at Columbia University, and we wanted to help as many developers as possible. That's why we're doing this startup. I'm going to show you some examples. Okay, so basically, you can actually go to like our website. If you have an app in Google Play, you can go to our website, and you can get some preliminary analysis of your app by going to this Play Apps tab, and you can search for your app's name. And I'm going to show you one example, which is the eBay app. If you search for eBay, some of these apps are pre-profiled. You can check out some of the results from the popular apps, for example, Facebook. Let's go to eBay. So once you upload your app, like after maybe 5-10 minutes, depending on how many apps are waiting to be profiled in our queue, you get this report page. We'll show you some basic stats like method count or file size. So this, a lot of you guys know that there's this 65K method limit. If you go above that, you have to use multi-DAX. Actually, multi-DAX gives you like 20% overhead in terms of app startup. And if you guys also know that this app size can be a very important metric as well, because the larger your app is, the longer it takes a user to download your app and install your app. So this is an important metric for app conversion. And you can also see like trending for these metrics. Here we see a spark line for the last few versions, and here you see that the app is actually getting larger over time. And you can also zoom in to see what the exact. Let me just move this tab over here. Okay. If you click on this method count metric, we'll also show you a breakdown of method count by SDKs, or like the modules the components in your app, so they can see which SDK consumes a lot of has a lot of methods. And if you scroll down, you'll see, here we actually auto-discover the actions in your app, such as, right here we click on a toolbar search icon, and then a new activity shows up. And for each of these usage scenarios, we benchmark the response time, we benchmark memory usage, network usage, and disk I/O. And also, we tell you the number of issues we found in each of these scenarios, and this crawling is automatic. If you want to look into more details for these scenarios, you can go to, for example, you can click on this issue, like right here, the number of issues, and we'll show you the details about each issue. If you look at this app, first of all, the app is getting faster all the time, which is the good news to know. And here you see we found 3 issues that block the UI, and these issues cause the app to be not responsive to user actions. If you click on this issue, we'll show you this visualization. This is called a flame graph, or sometimes people call it cost stack with times. Vertically, you see the cost stack, and the length of each bar shows how much time you spend in each method. You can see for this particular issue, the developers spend a lot of time doing this secure random constructor that's like 40 milliseconds, correspond to like 2 or 3 drop frames. And here you see the app is also doing a lot of data read in the UI thread that causes another maybe 2 or 3 drop frames. So this one call actually causes maybe like 5 to 6 drop frames. Okay, so we've seen a quick demo of what NemoDroid can do for you. And we measure a lot of metrics. I can spend a lot of time talking about all these metrics, but in the remainder of my talk, I'm going to focus on this one important metric, app start time. Because before a user uses your app, she has to start your app. So we're going to look at some common issues that slow down your app startup. There's actually 3 different types of app start. There is this cold start, which means the user hasn't run your app for a while, and then they started your app. And to load the app, we need to load the app's code, the app's asset, and we create these object activities that can take a while. And also, if a user uses your app like 3 to 4 times a day, then each of these app start would be a cold start. The cold start tend to have this high impact on user experience. And there's this special case called the first start. Essentially, like after installation, if a user starts your app for the first time, and we need to initialize more things, such as compiling DAX code, and also ask user for credentials. Sometimes app would also present a walkthrough, and this can be slower than cold start, but fortunately, it only happens once after each installation. And lastly, there's this also start called warm start. A user uses your app and then switch to another app and quickly switches back. So a lot of the app's activities, object and code and assets are still caching memory. So this actually can be very quick. And so we recommend that you focus on optimizing your app's cold start time. Try to limit your cold start time to be in under 2 seconds based on a lot of studies. Of course, depending on app-specific logic, if you build an app that requires a lot of resources, maybe it can be longer. But we looked at the top 100 apps. We've done a study, and turns out 30 to 40% of apps start in under 2 seconds, and 70% of apps start in under 3 seconds. Right? If you want your app to be one of these popular apps, make sure your app starts fast. So next, I'm going to talk about some issues we discovered in a lot of apps we analyzed. So far, we analyzed over 19K apps, and these are the top 5 issues that slow down app startup. The first one is a Java reflection. Second one is dependency injection. Third one is an app doing too much work in the UI thread, the main thread. And also, there's this issue, ClassLoader.getResourceAsStream. It's a popular construct to load properties, assets from your jar. But it turns out the implementation of this method in Android is really slow, and that caused a lot of apps to be very slow. And lastly, a lot of the SDKs have problems. If you're not careful, you use one of the SDKs that has some issues, the SDK may slow down your app. So let's start from reflection. So to understand the reflection overhead in Android, we created a set of macro benchmarks. It's actually very simple. If you look at this particular macro benchmark, we have this class, which is empty class, and we try to measure the time to create an object of this class without reflection, the first version, and with reflection, the second version. And we repeat this object creation a million times. And here are the results. We tried this on 3 different devices with 3 different versions of Android, and the y-axis shows you the time. As you can see, for pretty much all versions of devices and OS combinations we tried, reflection has 4x to 20x slowdown. And in particular, this Galaxy S3 runs 4.1.2 Dalvik, and then Google moved on to create this ART and release it in 5.0. I would think ART would be faster, but actually the reflection overhead in ART is like 25x. It's even slower than Dalvik. So we know reflection has a high cost. But how visible is this overhead to users? I'm going to show you, a real example. So New York Times Android developers have been working with us in the last for maybe like 6-7 months, and over the course of this collaboration, they made their app a lot faster, and they published a blog post about a lot of the issues they fixed in their app. So I'm going to talk about this one issue, which is reflection overhead. So this visualization shows the overhead of this reflective type adapter factory.getBound fields inside the New York Times app. And if you look at the trending curve here, and at version 5.10.1, this particular method consumes over 1 second CPU time, right? That's a whole lot of time during the app's startup time. And these guys, they found this, the New York Times guys, they found this problem, and they fixed it by using custom adapters, and they also use this immutables class to make sure that developers don't have to write a whole lot of custom adapters, right? So custom adapters, you can write them manually, but that's a lot of overhead. You can use certain tools to help you reduce the cost. Okay, so how do we reduce reflection overhead? Well, if you use reflection in Android, make sure you're very careful. If you use a lot of reflective operations, that can make your app very slow. In particular, if you're dealing with objects, serialization or unserialization, avoid reflective type adapters. Okay. So let's look at the second issue, dependency injection. It's a very popular software engineering pattern, and not just for Android, for Java, for a lot of object-oriented languages. But the problem is, on Android, certain approaches actually work really slowly. There are 2 popular ways to do dependency injection. You can either use RoboJuice, which injects dependencies dynamically, or you can use static dependency injection, such as the Dagger libraries, Dagger 1 and Dagger 2. And the dynamic approach actually turns out to be very, very slow. So we did macro benchmarks that shows RoboJuice is 5x or more slower than static approaches like Dagger 1 and Dagger 2. And we've seen like a lot of slowdowns in popular apps. For example, Skype has a 800 millisecond delay because of RoboJuice, and then later they switch to Dagger, and this dependency injection overhead becomes like 100 millisecond also. And we've seen that American Express, the app shifted from RoboJuice to Dagger, and they reduced the 1.7 second injection overhead. And Groupon and Fandango, right? So all these apps, these are very popular, and some of them already switched to Dagger, but some of them haven't switched to Dagger yet. And another interesting thing about RoboJuice is if you compare the number of methods in RoboJuice versus Dagger, RoboJuice actually has 10,000 more methods. If you want to avoid multi-dex limit, then that's another reason to go to Daggers. Okay, so my recommendation here is use Daggers for Dagger libraries for dependency injection. And based on our comparison of Dagger 1 and Dagger 2, Dagger 2 is slightly better than Dagger 1. So if you are willing to learn a new system and carry out the cost of switching, well, switch to Dagger 2. Okay, so doing too much work in main thread. So a lot of you guys already know these problems, right? Like your US thread is for responding to user actions. Therefore, you shouldn't do anything time-consuming, such as network operations or database operations or even like file system operations. And Android has this strict mode to help developers detect such issues. But based on our analysis of many apps, we found that there are just many other ways for the US thread to be occupied by work. For example, we've seen apps parsing a whole lot of data, right? Although the data is acquired through a background thread, but once the data is fetched from the network, the US thread spends a lot of time parsing data, and that can be slow. And we've seen apps doing crypto operations, secure random or like Bitcoin operations in the main thread, and a lot of initialization operations. So I'm going to show you one example in this Hollister app. So this is a clothing e-commerce app. And the guys who built the website clearly know that for e-commerce, response time matters. So all the pages at the site load in under 1 second, right? It's very fast. But the app, if you look at the startup time, actually it's really slow, and some users actually complain. After like an hour, the app is still not loaded. And it turns out the Hollister app spends a lot of time doing parsing. So let's look at a little more details here. So the version 3.1.2 takes 5.22 seconds to load. What's going on? So if you zoom into the code, you see a bunch of issues. They're doing data fetching, and also they're doing serialization and data parsing as well, right? So these parsing operations makes the app really slow. And then in the version 4.0.0, so developers move these operations to background. And now the app starts at 2.21 seconds, right? It's a lot faster than the previous version. Okay, so the idea here is, if you do too much work in your app, in the main thread, make sure you move the operations to the background thread. And another approach to reduce the cost here is to try to make your code more efficient. For example, if you're parsing data using JSON, and JSON uses reflective type adapters, that can make things slow, and try to use custom type adapters. Okay, so now I'm going to talk about this dreaded get-resource-as-stream problem. So if you look at this particular simple app, right? It's like really simple, fewer than 10 lines app. And all you do is to try to load the property from your app. And if you run this demo application on the Nexus 5, and if your app has 3,000 resources, pretty reasonable, you're going to get a 1.7 second delay, right? Just for this very simple 10 lines app. And if you write a similar version of this code to load a resource from 3,000 resources jar, and it takes like roughly 7 milliseconds on the PC. So what's the problem here? Turns out for many versions of Android, their implementations of this get-resource-as-stream are not efficient. The first time you call this method, the implementations, they need to basically index all the resources in your APK and verify that the APK is signed properly, and also parses the Android manifest file. Right? The delay here, the time you spend in get-resource-as-stream is actually proportional to the APK size. And a lot of the famous apps are affected here. Walgreens, Audible, Line. Right? So basically, 400 millisecond slowdown, 1.3 second slowdown, 1.7 slowdown. And you just shouldn't use this method at all, right? Try to avoid this method. If you need to load a resource, use Android's resource utility to load resources. Okay, so now let's look at SDKs. You guys probably use one, two, or a lot of SDKs in your app. The problem with these SDKs is that these SDKs can slow your app down. The code is not written by you. The code is written by the SDK developers, but you have to live with it, or you have to find a solution, right? So it's kind of hard. If it's your code, you can modify your code, make your code faster. But somebody else's code, first of all, you don't even know there's a problem there. Second, even if you know there's a problem, how do you fix it? So let's look at the data we collected based on all the apps we analyzed. So this slide shows the 10 slowest SDKs out there, like the SDKs that affect app startup. And you see here are here is the delay time. Is the unit is a millisecond, and here we list the app's name. You see TypeJoy, app development framework, Joda time. How many of you have not used the Joda time? Okay, so it's like two-thirds of you guys have used the Joda time, And SMAC, Amazon AWS, also very popular. Accelerator, simple login for Java. How many of you have not used simple login for Java? Okay. All right. So I guess the rest of you guys have used this SDK. And Google dependency injection. This SDK is really slow. So what's going on? Well, let's take one example, the JOTA-time, which is a very popular datetime library, to see what's going on there. So let's say you just create this simple app. You don't do anything with the app except you just create this object, datetime object from the JOTA-time library. And if you build this app, you run it on the next 5, you compare the time for this app to start versus an empty app without this line to start, right? Just compare the overhead of this particular line, and this new datetime object introduces 400 millisecond delay. And what's going on? Well, we've seen some real-world apps affected by this particular problem. And for example, Yahoo Fantasy Football has a 2-second slowdown because they use JOTA-time and initialize a datetime object in the class constructor. So the problem is this datetime constructor in JOTA-time actually calls getResourceAsStream. And we just learned that this getResourceAsStream is very slow on a lot of versions of Android. And how do you fix this problem? Well, if you want to use JOTA-time, you can provide your own fast data time zone provider. So there's a solution on Stack Overflow, or you can switch to Date4j, or then use JOTA-time for Android. Right? So these solutions help you avoid delay if you want to use a JOTA-time library. Okay, so we're curious how many SDKs are affected by this particular problem, getResourceAsStream. And so we looked at all the data we have, and turns out 20% of the SDKs out there, they call this getResourceAsStream. And a lot of the famous SDKs are out there, like Backsense, simple login for Java. And we also looked at what apps are affected. And some of these most popular apps, like Amazon Kindle and TuneIn Player, these apps are all affected by this getResourceAsStream problem. So overall, over 10% of the apps are affected by this problem. So is there anyone from the Android team here in the room? I'm just wondering when Google is going to fix this problem, right? getResourceAsStream, just make the implementation efficient. Okay, so to conclude, we know that performance matters a lot for user conversion and user engagement. We also know that to make sure our app is performant, we want to establish this performance optimization process. We want to continuously measure our app's performance to avoid regressions. And whenever we see regressions, we want to spend the time to track down the issues, fix the issues, and then measure again to make sure our fixes work. I want to repeat this process as often as possible, maybe for each pull request, each testing build, each alpha and beta release, to make sure that regressions are fixed at the moment they're introduced. I've also covered the top 5 performance issues we see in a lot of the apps we analyze. And I hope that by learning these, you guys can avoid the issues and make your apps excellent. So if you have thoughts and questions about our surveys, let us know. Drop by our booth. We have a booth in the Startup Alley. And also you can tweet to me, DreamPhoneY, or tweet to NimbleDroid. And we're also hiring an Android developer evangelist, basically a person who loves Android programming and also loves helping others, like by writing tutorials, giving talks, recording tutorial videos, things like that. Okay, so that's all about my talk. I'm ready to take questions. Oh, so maybe you guys can come forward because we don't have a microphone. If you ask a question, nobody can hear you. If you come forward, I can repeat the question to the audience. Okay. To measure startup? Okay, so the question is about how we measured app startup. So there are 2 questions here, basically 2 sub-questions. One is how do we get the timing measurements? The second is how do we know the app finishes startup, right? And for timing measurements, we basically use the Android's system's timer to actually monitor how long it takes for certain operations to complete. And your second question is basically how do we know app finishes startup, right? And so our approach here is, so if we take a third-party app or app we don't know about and want to measure startup time, we're going to run this app twice. The first time, we wait for the app's main activity to show up. And the second time, we just monitor to see that this activity shows up, and then we look at when the main thread of the app to be idle, and that's like when we say the app finishes starting up, right? So that's heuristic basically checks to see when the app finishes creating the main activity and the UI thread is ready to respond to user actions. So it's a heuristic we use to determine when the app finishes startup. Does this answer your question? Okay, great. Question? I'm sorry?
Does this work on pro-guarded API?
Okay, the question is, does our service work with pro-guarded APKs? The answer is yes. So if you have a pro-guarded APKs, your APK, you can upload the APK and we'll show you the reports. However, when you try to diagnose the issues, if the app is pro-guarded, you can see obfuscated method names. You can solve this problem by also uploading your mappings.txt file, right? Just like Crashlytics or a lot of the crash reporting services out there. So you just provide us mappings.txt, we'll translate the names back to, okay. Question?
What sort of device instance are you using to do the?
Okay, so the question is what device instance do we use to do the profiling? So right now we use Nexus 5s, and also the Android version is 4.4, because based on Google developer dashboard, 4.4 is the most popular, and this Nexus 5 is like 1 year or 2 year old device. It's like very representative of the mid-range device. Okay. Any other questions? Okay, I guess that's all then.